Alright, so we're going to start talking about the first derivative test. And if you have not watched the video that precedes this one, which is how to compute where the function is increasing and decreasing, I suggest you watch that one first because a lot of the material I cover there. So here's just going to be an application of what we learned there. So please go back and check it if you haven't. But if you have, we'll separate 4 different possibilities. So I'm going to do 4 different possibilities. One is where a function looks like this. Then the other one will be when the function looks like this, locally. Then the function doing something like this, and the function doing something like this. So we'll analyze those 4 different cases, and those are going to give us the whole idea of how to apply the first derivative test. So we know we have, it looks like from the graph that we have a critical number here, and the derivative, if you look at the slope of the tangent line here on this side, the derivative is going to be negative on the left hand side of our critical number. But when we go to the right hand side, the derivative is going to be positive because the tangent line is going upwards. So we have that the derivative goes from negative to positive. We're going to have a relative mean. So relative mean or minimum will occur when you have a critical number, firstly, where the derivative goes from negative to positive. So negative to positive. Now, in this case, we're going to have a relative max. And that's going to happen when your derivative prior to the critical number goes from positive to negative. So when you go from positive to negative on the signs of your derivative, you have a relative max. Then the next one, this one right here, your tangent line at the critical number becomes 0. However, you're going from positive to positive. So when you go from positive to positive, oops, I'm going to erase that. No parentheses needed. I'm just telling you what the sign will be. When you go from positive to positive, then you have that there's no relative mean nor a relative max. So let's call it no extrema. And in this case it's the same but just flipped, and in this case you're going from negative slope to negative. So when your derivative goes from negative to negative, there's also no extrema at that point, at that critical number. So one thing that we didn't mention, but we should, is that every relative extremum occurs at a critical number. But not every critical number is a relative extremum. Here are the examples of what things can happen. You can have a derivative being 0 and not having a critical number, or a relative mean or a relative max. I messed up there, but that's okay. Now there's another option here that we have to consider is when the tangent line becomes vertical, and that's when in that case your derivative will be undefined. So here we're going from a positive slope, which was very unfortunate drawing of it. Draw it again. So we're going here from positive to positive. But at this point, you see you have a point where the derivative is undefined. So you can have this situation happen, or these two situations happen as well when you have that the derivative is undefined. So in this case, you will be going from positive to positive, having possibly a infinite value for the derivative there. And in this case, then you have no relative extremum either. So what is going to be our strategy to classify extrema using the first derivative test is going to be the following. So our strategy is the following. Number one, you're going to find all critical numbers. Once you have that, number two, you're going to draw your real line and locate critical numbers and asymptotes, vertical asymptotes. Of course, you're only going to consider the domain of the function, so if you have to chop out a part of the real line because it is not in the domain, you do that as well. Then three, you're going to have to form your intervals or write down the intervals. And what are those intervals going to be? Those intervals are going to be the ones that will be given by partitioning the real line into the subintervals that are going to have endpoints at your critical numbers and asymptotes. So you mark all those points and then you find the intervals between them. All right, so 4, you're going to grab a test value for each one of those intervals. For the test values, you want those to be inside of the intervals. You don't want them on the endpoints. You want them inside. Now 5, you're going to determine the sign of the derivative. At each test value. And number 6, using this information here, you will determine your relative minima and your relative maxima, if there are any. Let's say determine extrema. So right there, that's going to be your strategy. It seems like a lot, but it's going to be really, really straightforward, really fast. We have, in fact, already done all this, with the exception of the last line. The last step is what we didn't get to do in the previous videos. All right, so let's take a look at this function. This is the first example, so we're going to go easy. In this example, we're going to try to determine all the relative extrema, either relative max or relative min. Now, we know that this graph right here is a parabola that opens up. So there's just, at least we expect there to be just one critical number, one relative minimum, and that's it. But let's verify. So step 1, find critical numbers, involves taking our derivative. In this case, it's 2x plus 8, and setting it equal to 0. Only to 0 because this is always defined, so I don't have to find the values where it's undefined. So in this particular case, I can get away with just setting it equal to 0. So subtract 8 on both sides, and we get negative 8 equals 2x. Divide by 2, and I'm going to write it here. X equals negative 4 is our critical number. As I said, we expected 1, and we got 1. So draw the real line and locate critical numbers. Negative 4, we're going to put it here. And vertical asymptotes, none. All right, so then we get our intervals. I'm just going to call it ints for intervals. It's going to be from negative infinity to negative 4, and then from negative 4 to positive infinity. That's step 2. Step 3. Step 4, find test values. So test values I'm going to pick are going to be numbers in these two intervals. So for example, negative 5, which happens to be to the left of negative 4. And let's say 0, because that's easy to evaluate, way far out to the right, but somewhere here is going to be 0. And so it's to the right of the critical number, but within the interval. So 5 determines the sign of the derivative. So we take the derivative here and we evaluate our test value. So -5 evaluated here. Let me do it just over here because I have some room. I want to put it all in one board so we can see it. So at x equals -5, we get that the derivative would be 2 times -5 plus 8, which is going to be -10 plus 8, -2. So all I care about is the sign, which is negative. When I plug 0, that one is easy. Thankfully, I don't think I have to write it. F prime at 0 is going to be 2 times 0. 0 plus 8, 8. So it's going to be positive 8. All I care about is the sign. I just want to know whether it's going from increasing to decreasing or from decreasing to increasing and so forth and so on. So determine the extrema. So this is how I do it. Negative means it's going to be decreasing. Positive means it's going to be increasing. So if you have a critical number in between, that critical number will be a relative minimum. So you're going from decreasing, negative, to increasing, positive, and you get a relative minimum. So your answer will be that there is a relative minimum at x equals -4. So I'm going to write it here to use the fact that I have space. So relative min at x equals to -4. A little bit disorganized. I just wanted to fit it here so we had our strategy visible. Now that we're comfortable with the strategy, I'm going to give myself more room because the functions will get a little bit more interesting, so we'll need more room. But remember these steps. These are the ones we're going to be using. All right, so let's take a look at this one. Just slightly more difficult, but again, step 1, find your critical numbers. So you take your derivative. You get 3 that multiplies 1/3, cancels. You get just x. 3 minus 1 is 2. Minus, drop the 2. Minus, just copy the 8. And here you try to, you firstly set it equal to 0, but at the same time I'm going to try to factor. So I write x minus 4, x plus 2. So the factor form of x squared minus 2x minus 8. And then what I have is that I have 2 critical numbers. X equals to 4 from setting this equation equals, or this monomial equals to 0, if you will. And I get that x equals -2 from setting this monomial equal to 0. All right, so we have the critical numbers now. We're going to do our real line here. So we're going to go from -2 to 4. So we're going to have our intervals. I'm going to move over here now that I do have this board available. We're going to have my interval. My first one will go from -infinity to -2. The next one will go from -2 to the next point, which is 4. And then from 4 on, because there's nothing else, so 4 to infinity. I want to pick test values. And I'm going to pick numbers that live within the interval. So for example, I could pick -3 here, that is within the interval. I could pick here 0. Well, 0 is closer to this side actually. 0, not drawn to scale. And then 5 over here. So I'm going to pick those as my test values. All I care about is that they are in the interval. I am not going to care what value I get, just about the sign. So I'm going to look at the sign of the first derivative. And so how do you do that? Well, we evaluate. And as last time, remember, this form of the derivative is better, because that one will give me the signs right away. So for example, at x equal to -3, you plug it in here, and so your derivative is going to be -3 minus 4. That's a negative number. I don't care about the number. It's negative. -7, but we don't care. Then you have -3 plus 2. So just plugging it in here. -3 plus 2 is negative. Negative times negative is positive. That's all I record. I don't really care for the value I get. I just care about the sign. Now, if I plug 0, it's probably easier to plug it here, as I was just saying that you can plug it in here better. It's going to be the same thing. But if you plug it here, you get 0 minus 0, 0 minus 8, negative. Again, remember, do not just alternate them. Evaluate them just in case. Because if there's a multiplicity that is not equal to an odd number, you may get that the signs don't change. So go ahead and plug it again. So if you plug it here at x equals to positive 5 rather, the derivative at positive 5 will be equal to 5 minus 4. I'm using the factor form again. 5 plus 2. Now you have 5 minus 4 is 1, 5 plus 2 is 7. It doesn't matter the number. Positive times positive, it is positive. So yes, they do alternate, but do not just do that. So what happens here at the critical number x equals to 2, negative 2 rather, you're going positive, so increasing, to negative, so decreasing. You have a relative max here at x equals to negative 2. Here you're going to be going from decreasing to increasing. You're going to have a relative mean at x equals to 4. So let's write our conclusion. F has a relative minimum at x equal to 4 and a relative maximum at x equal to negative 2. Now, if you were, this marker's causing us some trouble, but we still have x equals negative 2. Now, the one thing I wanted to say is sometimes you will be asked to give that what is the maximum value and what is the minimum value. What you would do at that point is grab the value that you obtain and plug it back into your equation, to your original function. So you would say the maximum value is, and I'm not going to compute it because I don't have my calculator with me, and I don't want to make mistakes. F of negative 2. So you would plug your negative 2 back into the equation to get your maximum value. Alright, so I realized that there's this video is already getting too long. So we have 2 more examples we want to go through. So I'm going to do it in the next video. So we're going to have 2 videos for this topic, which is okay. The more practice we get, the better. So I'll see you in the next video.